old school division, but we found that each of the place values represents a coefficient. So if my first one is 2x squared, what's my next one going to be? 5x, because the 2 is from here and here. So the next one after 2, since my next place value in the tens place over there is plus 5x, and then this plus 2. And then if you look at the bottom right, or bottom left, excuse me, I have a remainder of 3, so I rewrite it as a fraction. So coming back over here, so plus 3 over x plus 1. Move this up a little bit, make it look a little prettier. And there you go. Questions? This is not new. What's going to be new is the next thing we're going to do. How to get which? The 5x, the 2, which part? So if you look, 2 goes with the 2, and the 5 goes with the 5, and the 2 goes with the 2, and the remainder goes with the remainder. That's all. Okay. So we did this before. You can still do the old school long division. Speaking of long division, that last quiz you did, yeah, they're graded. And they're in the portal. And some of you need to read directions where it says, use the box method or long division. And somebody just gave me an answer. You get full credit. You don't show me work when it says use the box method or long division. The only ones you got full credit for not showing work were the 3 multiple choice. And I was very generous even there. Okay. All right. Fuel economy, 2000. EPA reported combined fuel efficiency for cars that assumes a little bit more than half the time on city driving and a little less on highway. You think that's going to be true in Arizona?
No.
We have a lot of highways here. Okay. So, several conventional cars. What would be a non-conventional car that probably does not follow this? Lamborghini, yes. What? Okay, electric car. And anybody's family have a Prius? Okay, so Prius has kind of a unique technology. It has what's called regenerative braking. And when you're driving around the city, you actually get better gas mileage than you drive around on the highway because the regenerative braking, you don't need to use as much gas when you're driving around the city. So since you're not using as much gas, because that regenerative braking sends energy back into the engine, I don't exactly know how it works, they actually get better gas mileage around the city, but it's still pretty good. Do you know what your gas mileage is? It's probably around 40 to 50 miles a gallon. Okay, and on the highway, it's probably a little less than that. All right, so here is the equation I give you. But they have 2 variables. But then down here, they tell you, well, highway driving is about the same as city driving plus 10. So what you're going to do is you're going to rewrite this expression here, substituting in the x plus 10 in for the h. That's step 1. And then step 2, you're actually going to do the division. I don't care if you use long division, synthetic division, or box method. Okay? So try 1 and 2. Right here. Make an equation. Put the fraction bar in. Up top, put 100x. And then in place of the h, make a set of parentheses. And we're putting in x plus 10. So right next to the 100x, parentheses, x plus 10. On the bottom, put in 55x plus 45, and then in parentheses, in place of the h, put in x plus 10. Distribute on the top, distribute on the bottom, and then simplify, and you're done with step 1. Step 2 is after everything's simplified, you actually do the division any way you like. So let's distribute, combine like terms, and follow Layla's lead, and we're going to simplify before we do the division. Okay? All right. So up top, what do you got there, Alex? I'm sorry? 1,000 x. Don't forget the x on the end. Take that whole thing, divide it by. So distribute 55x plus 45x plus 450. Okay, and then we're going to combine like terms. So that's really going to be 100x, right? There's lots of zeros there. Can we kind of take care of some of that? What's my GCF of 100, 1,000, 100, and 450? Somebody's picked up on. One more time, Joseph. 50. Okay. 50 divides into all of those. So let's use that. Okay. So 50 goes into 100 two times. Goes into 1,000 20 times. On the bottom, goes into 100 two times, and then 450 9 times. Okay. At this point now, do we do step 2? So take a few moments and now do the division any way you like. Synthetic works, box method works, long division works. Find your quotient and your remainder. First of all, I am solving, so I'm going to do this off to the side. 2x plus 9 equals 0. When I do that, I get negative 9 halves. So negative 9 halves. I'm going to make my little backwards L. Beep and bop. And then I've got 2. I'm going to put a couple of spaces in here. And then I got 20. And I'm going to put my line underneath. I'm going to drop down my 2. 2 times negative 9 halves is negative 9. And then come down here, and 20 minus 9, whoopsies, is 11. Okay? So I got 11. And what am I going to have after that? Where's my remainder? What should go next to the 20 up here? I have 2x squared plus 20x plus 0. Okay? So put a 0 in there. So 11 times negative 9 halves is, what's that going to be? What's negative 9 halves times 11? A little messy, huh?
Negative 49.
Negative 49.5. Okay. So negative 49.5. And I like the fact that we're sticking with decimals at this point because otherwise the fractions get a little messy. And come down here, and that makes it positive 40. We're adding? Oops, keep doing that. Oh, don't give away that. Backspace, 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 backspace. Okay. So negative 49.5 would be my remainder. Okay. So now what I have to do, I have to cut everything in half because of the half. So it's not really 2x plus 11. It's going to be x plus 5.5. I'm going to write as a decimal. And then plus, make my fraction bar. Now, remember, I have 2x plus 9 on the bottom, right? So up top, I'll remind myself what's going on here. What do we have on top? We have 49.5 because we already got the 2 there. Okay, so negative 49.5. Now you could have done this using box method. You could have done this with long division. Any of those ways work. All right. Now it's time to take a look at what happens to these graphs. So first step, I'm going to scroll down a little bit. There are 5 equations. Do you think I'm going to make you do all 5? No. No, I'm not that mean. Okay, so I'm going to make a few of you do one at a time. And then we're going to share our knowledge. I'm going to fill in the rest of this table. Okay? So here we go. This group. Emilio, put it away. 1. In the bag, not there. I've already heard your issues with your phone. I don't want to have them in here. In the back, on the side, you're doing number 2. Okay? This group. Third equation. Okay. This group, that group. Fourth equation. These 2. Fifth equation. All you're doing is you're finding the degree of the numerator. You're finding the degree of the denominator. You're going to do the division. And you're going to, well, we'll do the end behavior together. Okay? So do the first 3 columns. Degree, division. Just to the one I gave you.
What'd you give me?
You get there. Give me my wild card, whichever one you want.
I want a challenge though.
Negative 49.5 on top. Desmos is not going to help you with the degree. So far we've done H and J. Pretty easy. I think you'd agree that the rest of these are also pretty easy. The division, not so much. Okay. Where's my 4s? Okay. Degree numerator? 3. Degree denominator? 1. All right. Okay, last one. Where's my 5s? Degree numerator? 1. Degree denominator? Okay. Notice how I saved the first one for last because a lot of people get tripped up by this. Okay. What you get for the degree of the numerator? How do you know it's 0? I don't see a variable. Because it's really x to the... Okay, so my degree of my numerator is 0, but my denominator is going to be... All right. So now, I hate when it changes colors like that. It drives me crazy. All right. I'm going to give you a little bit more time. Just do the division. Just for the one. Just the one I gave you. Okay, just do the division. Go back and look at the end behaviors. Okay? This one, a little more straightforward. Okay? In the back, number 2. Layla, what'd you get? Yep. So negative 19, right? Over x plus 2. So that's the second one. Third one's a little bit different. We haven't done one like this. Where's my third group? What do you got, Joseph? Okay, so notice it's the first time we have a variable in our answer. We've done division before like this, but the graph's going to look a little different. 3x plus 1 plus negative 7 up top. Yep. X plus 2. Okay. So the good news is, are my divisors the same, or are all the same except for the bottom one? All right. Oopsies. Where are my 4s? All right, Camilla, go. What do you got? 2x squared. Okay. Minus x plus 9, and a whole bunch of stuff, right? What's my remainder? All right. Hey, Sydney. What's my answer for this one?
0 plus x plus 2 over 2x plus 3x plus 7x.
So the first and the last are basically identical. And we're going to see why when we take a look at the graphs in just a minute. Okay? So when you have a situation like this where your numerator has a smaller degree than the denominator, what's your answer always going to be? It's always going to be always going to be 0. Okay? Because, I mean, think about it. I'm dividing a smaller number into a bigger number. And the further I go, as x gets bigger and bigger and bigger, the bottom gets bigger and bigger and bigger, and the numerator doesn't get so big. So if I divide a number that's bigger and bigger and bigger, and the number's not so big, the answer's going to be 0. Okay. All right, let's take a look at what these graphs look like. We're going to take this nice and slow. We're going to do the top one and the bottom one last. Start with the second one. Type in 7x minus 5, and don't bother with the h part, over x plus 2. So go to Desmos if you don't have it open already. Make fraction bar. 7x minus 5, was it?
Yes.
Minus 5 over x plus 2. What was my answer? 7, yeah? Hey, look at that. What's that look like? Not vertical, but
Horizontal.
my horizontal asymptote. Okay? So far, so good? Starting to make a little more sense now? Okay. So let's take a look at the second one. So, you know what? I'm not going to rewrite it. Okay. So 3x squared plus 7x minus 5. This one's a little trippy. 3x squared. What was it? Was it plus 7x minus 5? Is that the rest of it? Yeah. Okay. Watch. Watch. Whoa. Is that horizontal? Is it vertical? It's neither. We have a new flavor of asymptote today. Okay. So let's come back here. What was my answer before I got my remainder? 3x plus 1. So, whoopsies. Y equals 3x plus 1. It's still an asymptote. But it is neither horizontal nor vertical. So, where are my people who are in sports med? Okay. What are these?
What?
What are these?
What?
Outside the rib cage. What muscles are these?
I don't know how to say it.
They're the lats.
Yeah.
Also, down around here is the what? Nobody?
I never said I did it. No, like that's the last of this.
Oblique.
Oh.
So we have a new type of asymptote. So oblique asymptote are at an angle. Okay. It's basically the equation of a non-vertical, non-horizontal line. Okay. So line, not horizontal or vertical. Okay. You should just sit closer. It's not letting me zoom. So when in doubt, watch this. Bam. How's that? Better? Got it? Okay. All right. So for j of x, I have what's called an oblique asymptote. And my oblique asymptote is the equation y equals 3x plus 1. Okay. Let's start talking about end behavior. So on this one, what did this approach? What number did it approach? 7. So this one's going to be a little bit different. A little control A, control C. This one's going to approach not 7, but 3x plus 1. What do you think the top one and the bottom one approaches? Danica? 0. Okay. So because my answer here was 0. So approaches 0 on the top. On the bottom, 0. Okay. Once you got that down, I want you to think about what this one does. Think about what it approaches for my end behavior. Okay, so just think about that just a little bit. I'll give you just a minute. So Whenever you just get a polynomial bigger than 1 degree, we're just going to call this infinity. Okay. All right. So we completed the table. What I want you to do is I want to see if you can kind of figure out a pattern here so we can make some generalized statements. And what I want you to focus in on is the degree of the numerator versus the degree of the denominator. So we should be able to make 3 specific statements about comparing the degree of the numerator and the degree of the denominator and the end behavior. So take a couple minutes and see if you can do that one. Generalized statements. Top and the bottom one. They're not exactly the same, but they have something in common. What do they have in common? The degree of the numerator is what compared to the degree of the denominator? Less. Okay, so let's start with that one. Okay. So, text box. There we go. So when the degree